This is a variant of a question on principle of moments, and you are asked to determine the size and the direction of a force that you need to exert on X to balance the plank. So the strategy to use for this question is we will first find out what is the total clockwise moments. We will then also find out what is the total anti-clockwise moment, and we see which one is bigger, and therefore what is the balance moment needed uh, to balance the whole beam at equilibrium to prevent it from rotating. And with this balance moment, we can then determine at X what value of the force is needed to create this last remaining moment to balance out everything, and also the direction of this force. So there is it upwards force on X to create a clockwise rotation, or is it a downward force at X to create an anti-clockwise moment? So let's get started. The answer is B. Double check your answer. And the moment caused by the 12 Newton force is an anti-clockwise one. If you need help with this, just model the whole scenario. And the value of this moment is 12 newtons multiplied by perpendicular distance of 2 meters, getting me 24 Newton meter. We do the same thing for the 8 Newton force. That will create a clockwise moment. And we can see that now just having these two forces on the beam, there is an excess of anti-clockwise moment, which means that the whole beam will now rotate anti-clockwise. If we want to keep the beam at equilibrium and not rotating, then we need an additional clockwise moment of 8 Newton meter. And how can we create this additional 8 Newton meter of clockwise moment? By exerting a force at X. So I use the moments equation. Force at X, I'll just let it be F, and the distance away of X away from the pivot is just 4 meters, and I need to create a 8 Newton meter additional clockwise moment, and that's how I can get a force of 2 newtons. And the direction of force at X needs to be downwards, because when you press downwards on X, it will make the plank rotate clockwise, which is exactly what we need, an additional 8 Newton meter of clockwise moments.